Hello guys and girls, Raj here, back with another video. In this video, we are going to discuss EventBridge versus SQS versus SNS, when to choose what factors to consider, etc. This video will also serve as a EventBridge deep dive. If you are new to the channel, a little bit about me. I'm a senior specialist SA for serverless and container working at AWS. I'm also a published Udemy Pluralsight author, and in free time, I like to play video games. Alright, so we are going to start with basic definitions of SNS, SQS, and EventBridge so that you have the basic understanding of the service. Then you are going to jump into the differences in all these different factors. As always, I'll put the timestamp in the video. So starting with the basic definition and very basic difference. Starting with SNS or simple notification service, here you publish a message to the topic and there could be one or multiple subscribers to the topic and they will all get this message. So this is essentially a push mode of working, so the same message can be pushed to multiple subscribers. Moving on to SQS or simple queue service, here a message is put to the queue and then a consumer can read the message from the queue and process it. So the basic difference between SNS and SQS, as you can tell, is SQS can have one consumer for that one message. You cannot send the same message to multiple consumers with SQS. And SQS is essentially a pull model because consumers are pulling the message from the queue. Moving on, next is Amazon EventBridge, where the messages are sent to an event bus, and then there could be multiple subscribers to this event bus, and that message and this message could be sent to multiple subscribers. This is also a push model. So as you can tell, there are a lot of similarity between the functionalities of these three services. So now let's jump into the differences. So on the scaling and concurrency controls, SNS service automatically scales. You can use lambda per function concurrency setting to control downstream consumption. SQS also automatically scale. Use lambda trigger batch size setting and per function concurrency setting to control downstream consumption. EventBridge also automatically scales up. However, SNS and SQS can literally scale up to infinite. For EventBridge, the soft limit is 400 put events on the producer side and 750 target invocation requests per second. But of course, this can be increased. You can use lambda per function concurrency setting to control downstream consumption. Alright, next is conditional message processing. By conditional message processing, I mean depending on some values in the message, if you want to send it to different consumers. So SNS, it can invoke different subscriber based on values on message metadata using SNS message filtering. SQS, you cannot decide the consumer based on message. However, one technique is use SQS with SNS message filtering to achieve this. Now, EventBridge, this is EventBridge's superpower. Event filtering can route messages to targets based on message. You can even transform events, like you can transform the message before sending to target. So when I say events, that means basically the message that's in the event bus. And it can also contain schema registry. So let me dive deep in this because I'm sure some of you did not get this part. So starting with SNS, so the way SNS message filtering works is, let's say you are sending messages for all kinds of loans to SNS topic, and you can say if the message has, let's say, the loan type as home loan, send it to this lambda consumer. If the loan type is car loan, send it to this email consumer, and also for all the loans you want to send a SMS. So you can do conditional message filtering with SNS. However, you cannot replace parts of the message and you have to define the metadata clearly, so it's not super flexible. Now with EventBridge, so on the left you can see the message. it can create the schema. It can auto-discover and create the schema. So you can see on the left, let's say we have this account, time, region, etc. And on the right, it's showing the event structure. So it says account type is string, detail type is string, ID is string. EventBridge can read messages based on this schema and do conditional filtering. And also, you can save all different schemas in a schema registry in EventBridge. So you can store all this schema in a central location. And if your consumer wants to process the message from EventBridge, not only it can create this schema, it also generates a code binding that you import in your code, and then you just directly start reading the message and then process it. If you want to do the same thing with SQS or SNS, you have to do it yourself, right? So you have to know the structure of the message and you have to codify it in your code. So EventBridge helps you in here. Also, EventBridge has lots of predefined schemas available. So this is the screenshot of schema registry. On the left, you can see schema registry and schemas, and it has bunch of schemas. Let's say for AWS Athena query state change, it has given the schema structure for that. And not only that, it has schema structure for a lot of third-party SaaS provider as well. So I'm going to come to that in a second. So going back, not only it can create schemas from messages, it can automatically discover schemas as well. So all the messages can keep coming in the event bus, and you can say, hey, if there is some new message that does not conform to any schema, discover it and create the schema for me. So it is going to create all the schema, put it in schema registry, and then you can go to that event bus, download the code binding for those new schemas, and then import it on your code. So since EventBridge can handle and read these schemas, you can do a lot of pattern matching rules. You can say, hey, if the time field in the message starts with 2017-10-2, then invoke this target. You can also do numerical comparison like, hey, if the detail field C count is numeric and it is greater than 0 but less than or equal to 5, etc., etc. Or if the source field in the message is anything but AWS EC2 or AWS S3, then invoke these targets, etc. And these are just few examples. This is, as you can tell, SNS, SQS, you cannot do this. This is super impressive in EventBridge. You can also do message transformations since you know the schema. So let's say on the left, you say, hey, I want to send the messages as instance, and then this instance is a variable within parentheses, is in the state. So this instance and state, it is expecting in the message. So a message comes in the event bus. Using the schema, it is going to read the instance field and state field, and then it is going to create the message. So on the right in the output, we assume that the instance field is this I-01234, and state is running. It extracted it, created the message, and then send it to the target. So there are a couple more examples of this. So look up the EventBridge documentations, and then you can see there are a lot of event pattern matching and message transformation. This is also unique to EventBridge, not available in SNS and SQS. SNS, SQS, you cannot transform the message in any way. All right, so how does it look? So a message can come to event bus, and you can have multiple rules running on that message. And depending on the rule, you can have multiple targets. So let's say the message comes and you run rule 1. If rule 1 is based on some pattern matching, if that pattern matches, it is calling lambda, EC2, and another lambda. Rule 2, in case rule 2 is satisfied, then it can call, let's say, AWS batch, step function, and an API gateway, REST API. So pretty handy. because of the schema registry and its flexibility to adopt new messages, EventBridge is integrated out of the box with multiple SaaS providers. So you can configure like maybe Zendesk creating a ticket. As soon as the ticket is created, it is gonna put it into an event bus. An event bus is gonna call a step function which is doing some machine learning that is gonna figure out the severity of the ticket. It can also integrate with PagerDuty, Datadog, and many more. These are just few examples. All right, so moving on, message replay. So SNS, once messages are delivered to subscribers, the messages are gone. You cannot replay the same message. Same with SQS, messages are gone once delivered to subscribers, no replay functionality. EventBridge, messages can be archived based on rules. So you can say that, hey, for this event bus, if the messages satisfy this rule, archive it, and then you can replay later. So what is the benefit of that? So when you are testing your code, maybe there is some bug, right, in the code, or it's not processing it correctly. You can make EventBridge to archive it rather than your producer sending the same messages over and over for your testing. So you run your code, you archive the messages, then you go check your code, you change something, and then you run your EventBridge messages again, and then you go check your code. So it's pretty convenient. Now moving on to message ordering. So SNS can maintain message order. Now we have a new feature called FIFO SNS. So SQS FIFO queue is a little bit older. So SQS FIFO queue maintains order. EventBridge message order is not maintained. Moving on to encryption and compliance. So SNS messages at rest can be encrypted using KMS. Both customer managed and Amazon managed CMKs are supported. It is also FedRAMP High, HIPAA compliant, and there are a lot of other compliance, but I just gave these two because these two are very popular. SQS messages at rest can be encrypted using KMS. Both customer managed and Amazon managed CMKs are supported. SQS is also FedRAMP High and HIPAA accredited. EventBridge messages at rest cannot be encrypted using KMS. It is HIPAA compliant. And then I gave the link. So in this link, if you go for each AWS service, maybe you are a financial institution. So PCI and SOC compliance is super critical to you. So you can go check for each service, not only SNS, SQS, EventBridge, and see what accreditation they have. Next, durability. So in short, all these three services stores multiple copies of the same message into different availability zone. So even if in an unlikely event of a availability zone failure, your message is safe and durable. Next is pricing. Again, these are public pricing. I'm recording this video, what day is today? This is November 12th, 8 o'clock in the evening. So these are all public pricing. SNS per million messages costs 50 cents. SQS per million messages 40 cents. EventBridge per million SaaS, custom, and cross-account events are $1. So SaaS is pretty self-explanatory. So those third-party integration, Datadog, ZeniDex, etc. Cross-account events are also pretty self-explanatory. Custom is when your application is creating a message and putting it into EventBridge. Same account AWS events are free. So AWS events are the events that AWS service produces once something happens. So let's say you are running EC2 and EC2 is terminated, or a new EC2 is being created, right? So in that cases, CloudWatch creates the events for the EC2, like an event for EC2 stop, EC2 start. Those are the AWS events. So for those, EventBridge is free. Next is persistence. So for SNS, no formal persistence model beyond delivery retry logic, and then it can the message can stay in the SNS for potentially up to 23 days. SQS, by default, messages are stored for 4 days. This can be modified to as little as 60 seconds or up to 14 days by configuring a queue's message retention period attribute. For EventBridge, no formal persistent model beyond delivery retry logic that extends up to potentially 24 hours. So one thing to keep in mind, let's say you have configured bunch of rules in your EventBridge and a message comes and it does not match any rules. So what's going to happen is the message going to get deleted after 24 hours. So what we recommend to customer is create a catch-all rule, like any message will go to this catch-all rule. So even if it doesn't satisfy any other rule, at least the messages will go to the consumer and then you can do investigation later on. Consumption, so out of the box, SNS consumer, so the SNS subscriber to the topic can be a Lambda, SQS, email, mobile push, SMS, HTTP. And for Lambda, because Lambda is the most popular one, it calls the Lambda synchronously, and SNS can fan out to multiple subscribing Lambda functions for the same message. For one guidance is you can use message filtering to control which messages go to which subscribers. So we talked about this in a couple slides before. Now remember, SQS is a pool model. So Lambda can pull from SQS. It integrates out of the box. Or you can read from SQS using any compute service that run AWS SDK, such as EC2, EKS, etc. So you pull the SQS, look if there is any message. If there is, get the message. If there is not, then you wait and you pull again. Talking about Lambda, Lambda service does this for you. You don't have to code this out of the box. Lambda service pulls messages from queue and invokes Lambda on your behalf. And it scales the polling based on the number of in-flight messages. Guidance, you can call message delete from within your code or let the service handle it via successful Lambda function execution. So I actually have a deep dive on this, like should you let SQS delete the messages when something goes wrong, or you let your code delete the messages explicitly. So I'm going to link it up top and you can go take a look at that video. EventBridge integrates with a lot of AWS consumers. Out of the box, it has the most amount of integration. Some popular ones are Lambda, EC2, step functions, API gateway, etc. And Lambda, it calls asynchronously. And again, EventBridge, like SNS, can fan out to 5 targets per rule and multiple rules on the same event source, 300 rules per event bus. So rules are like the event matching that we went through. If this field is this, then do this. So moving on to retry or failure handling. For SNS, let's say Lambda is subscribed. If Lambda is not available, SNS will keep on retrying for 23 days. And then if you do not do a DLQ, it will get discarded. But the guidance is use a DLQ or dead letter queue. That uses SQS queue with SNS. So in case your consumer fails, it can go to the DLQ. So similarly for SQS, use DLQ. So if your consumer keeps failing or something goes wrong, you can put it into DLQ. Same for EventBridge. EventBridge also has a dead letter queue. This is a new functionality, so always recommended to use dead letter queue. So in case something goes wrong, you can go to dead letter queue and then check what went wrong. So all right, summing it all up, so there are multiple factors. It's not like, oh, EventBridge is the newest, most shiny service, so I should use EventBridge. Consider the pros and cons. So cons of EventBridge could be if your security organization requires the messages encrypted at rest, you cannot use EventBridge. If you want the strict message ordering out of the box, you cannot do EventBridge. If you want to keep message ordering, you have to add some kind of sequence or timestamp into the messages and do it on the consumer side. Also depends on the scaling requirement. However, if your system is going to have different kinds of messages, you want to transform messages, you like the schema registry and you have a use for it, then EventBridge, of course, is a very powerful service. So consider all these factors and then decide. Alright guys and girls, that is the video. If you like this video, please do all the YouTube stuff. Click like, subscribe. If you have a question, put it in the comment or put something in the comment. YouTube algorithm really likes that, and then it makes this channel grow and it makes me more motivated to do more videos for you guys and girls. Also, November, December are big time to prepare for interviews, study something new. So I have a couple of courses out on DynamoDB, CloudFormation, CDK, Kubernetes, serverless. If you want to take a look, please take a look. That helps me a lot. But if you're not interested, no worries at all. I love you guys and girls anyway. All right, with that being said, I will see you guys later.